Hello everyone, my name is Christopher Wright. I own Citadel Systems here in the Little Rock area. We work with smaller businesses to help them understand cybersecurity, meet any kind of compliance requirements they have, and really just customize the big company security that's out there to fit these smaller organizations. I've presented this web application testing kind of introduction on Tuesday, March the 7th, or sorry, March the 6th for Central Arkansas Hackers Group. We had some technical difficulties, so I wanted to come back and record it as kind of a screen capture in case anybody wanted to come back and review it and use it, take some notes off of it to get started. A little background on me. I've been working in security for about 15 years now. For about 4 of those, I actually did vulnerability assessments and penetration testing for the federal government. And in that penetration testing, most of the time I was doing that, I was acting as a web application penetration tester. So I know this gets a lot of people excited. There's not a whole lot of people out there that do that, especially not in the area. And so I think a lot of people really wanted to see a good presentation on this and have some things that they could use to get started in that area. So that was why I was asked to put this together and why I was happy to put it on. Unfortunately, the live stream I had some technical difficulties in Facebook, and we also had some network difficulties on site at the Innovation Hub. So I wanted to come back and do this again just so that someone had a solid presentation to work off of. So I originally started this as a WebGoat presentation, but I wanted to expand that because really WebGoat walks you through everything in itself. So it would have been about a 2-minute presentation of how to get it going, and anything more would have given away the real magic of WebGoat. But I started thinking about it and realized that that's just a small portion of what we do when we do web application testing. So I wanted to step more through what we're looking for, specifically in controls and best practices and flaws and vulnerabilities that we're looking for when we do test. Talk about some of the tools that we use when we're testing, and this is probably a lot broader than you think it is. And then walk through some of the resources that are out there to help you in learning how to do this. So to start, let's look at some of the controls and best practices out there. And I use controls and best practices because people understand that when they're looking at things like HIPAA compliance or PCI DSS or ISO 27001, they understand that there are distinct controls out there. With web application testing, you're more looking for flaws. Those flaws can fit within the controls of compliance requirements, but they're not individually compliance requirements in themselves. And we'll go from kind of high level down to the compliance frameworks themselves. But let's start at the top with OWASP Top 10. And anytime you talk about web application security or web application testing, OWASP is going to come up. That's the Open Web Application Security Project. It's a large collection of recommendations, different tools that are out there, and just generally a clearinghouse for anything that has to do with web application security. So as you can see, there's conferences that go on. There's panels that deal with different areas of it. There's guidance, recommendations. There's tools. And so we talk about a lot of this. It's just a great repository for that. But we're going to start with the top 10. And this is the top 10 application security flaws that are out there. This document was recently updated towards the end of 2017. It's a very easy read. As you can see, it's 25 pages. Not a big deal. I'd recommend reading it all, but if you just absolutely don't have time to read it, come down to page 6 and look at each of the top 10 themselves. As you can see, the number one is injection. I'm sure that most of you would expect that. The biggest flaw that's out there in web applications is injection, and that is SQL injection as you expected, but that's also OS command injection, LDAP injection, and really any other way to work through the application to send commands to an underlying system, whether that's the OS or whether that's a database or whatnot. So that's kind of the top of the list, but if you read down the list a little bit more, you'll see it's not all the flashy things you think about when you probably think about web application testing. There's a lot of mundane things that needed to be tested as well. Things like sensitive data exposure, where you're looking for, something even so mundane as sensitive information in source code. If somebody left a comment in there, broken access control, broken access control. Looking at things like how can I escalate my privileges in a vertical manner from a regular user to a manager or to an administrator, or from over horizontal separations from maybe one client to another client that I shouldn't have access to. Security misconfigurations, things that might not be configured as strongly as possible with the underlying frameworks and systems, databases, web servers, things like that. So if you just read this one page, you'll have an understanding of kind of the top flaws that are out there that we're looking for. But if you go down to the next 10 pages, you can look at each of these flaws in detail. And so, as I said, I recommend reading all 25 pages. If you absolutely just can't read all those, then these 11 pages here are what you need to focus on. From there, we can look at two other areas, SANS Top 25 Programming Errors and Common Weakness Enumeration. And I link these together because SANS Top 25 really references CWEs. And I'm going to make the assumption, maybe incorrectly, but that everyone watching this knows what a CVE is. I can't remember the acronym actually. Common Vulnerability and Exposure, sorry. But that's where a specific vulnerability is related to something that's very focused in a certain piece of software or a group of software components. So for example, CVE 2017, 5754, 5753, and 5715 were all related to the Spectre and Meltdown vulnerabilities that were released at the very beginning of this year and assigned last year. What CWE is a little bit more of an open-ended designation. It doesn't necessarily say that this specific flaw in this specific piece of software. It says this kind of flaw anywhere it can be found. So you might have a CVE that is for the exact same flaw that a CWE references, but that CVE will be in a specific piece of software. So SQL injection in general is CWE 89, but SQL injection in a specific web framework like WordPress would probably have a CVE 2018-2737 or something like that. But as you're reading through the SANS Top 25, notice that we're picking out specific CWEs to reference here. These are good to understand what CWEs are related to web app security flaws specifically, but also it goes into a little bit just more programming flaws here too, with things like buffer overflows, missing integrity checks, and things like that. These things are a little bit more fluid. They can be part of a web application. They can be part of a thick client application as well. But the SANS Top 25 really narrows it down to specific ones. If you were to go to cwe.miter.org, you could get lost in there just like if you were reading through Wikipedia one day and just continue to follow hyperlinks as you read and learned. Going to the SANS Top 25 really narrows it down and gives you kind of specific focus on those areas that you might want to learn about immediately. And these all pile into the greater compliance frameworks, not really directly. You're not going to read NIST or HIPAA or PCI DSS and it's going to say CWE number or OWASP Top 10 number 1 2017. But there are areas once you understand a little bit more about what these flaws are with OWASP or CWE references under them, you're going to be able to look at those HIPAA controls or the PCI DSS controls or NIST controls and say, oh, that's where that fits in. So things like broken authentication, access control, broken access control, those are going to fall into specific controls under NIST and HIPAA and PCI DSS. And so when you do find those flaws, when you're doing a web app pen test, you can build that reference so that someone can look at that from a compliance standpoint and go, oh, that's why I need to fix that. It's not just something out in the ether that my web app pen tester found and is not really that important. Because really when you're talking to people in a business, they need some reason to fix that. And unfortunately, the fact that it's broken doesn't necessarily always convince people to fix it. So tying it to these greater compliance frameworks is really what it takes in most cases. So now let's dig into the tools a little bit. And as I said when we went through the introduction, it's probably a lot broader than what you think. When you're looking at a web app and you're testing it, you're not just going to hop into the browser and immediately go to the app and start testing that. You want to start at a much lower level. So in this case, you want to start kind of like if you're going to doing a network level pen test, or if you're doing vulnerability scanning or something like that, and start with network scanning or network scanning. Sorry, and with that, probably most of you will know that that usually means mmap. And I will use a VM that I've got running on here locally to demonstrate that. And so what I'm running here is just a standard mmap scan. I've told it not to ping. I don't care about pinging. Assume that host is up. Try to fingerprint whatever services you find open. Only scan the top 10 ports. mmap has a prioritized list of ports that are from the most found, through, I don't mean thousands, tens of thousands of ports that are kind of prioritized based on the most used. And then the IP address. So when the results come out from that, I can see that I've got port 22 SSH open, I've got port 80 open, I've got 139.445 open, I've got 443 open. I can look and see these things, see if there's another way into this system. An example that I use that from my testing past here is that an application may have the user interface on port 443, but it may have an administrator interface somewhere else. Remember, I said that the application doesn't have a specific structure or required framework. Whoever's designing this application can design it in any way that they want. So they can completely separate out the administrative functionality, or any functionality really, but in this case the administrative functionality, and put it on a completely different port. Say they put administrative functionality on port 4443, and you hop on and you jump into the browser and start trying to hack your way into the main user application on 443, and you say, well, I can't get in there. This is pretty solid. I'm not going to be able to get in. But you don't look at the administrative functionality that's on port 4443 that's extremely poorly written and just kind of thrown together, that you could have got in with a simple SQL injection, or maybe it didn't have any kind of real access control in it at all. And so you missed an entire threat vector into that application just because you jumped right into it through the browser. So with that, we see that we've got a web server here running on port 80 and port 443. Looks like it's the same web server, probably the same software, just opened up on both ports. We can look at that a little deeper using a tool called Nikto. And what Nikto is going to do is going to go look at some very basic web server things. It's going to look at the software that's running. It's going to look for some common directories that are out there. It's going to see if it can browse those directories and get a file list out of there. It's going to look at your methods that are allowed. It's going to look at some of the basic functionality that's in that root, the root index HTML or index PHP or whatever file is the root there. It's not going to spider through the application. It's not going to try to do any kind of magical stuff beyond just looking at that, kind of looking at the front door, really. And as you can see here, it's fingerprinted similar to what Mmap reported, that we're running Apache 2214. It's saying that Apache 2214 appears to be outdated, which it is. The latest Apache is 2.4 something. That says 2.412. But that looks like it's a little outdated, actually, because Apache 2.2 is no longer supported by the Apache project. So there might be some flaws we could look at in Apache 2214. Anything from Apache 2214 and on, we could see if there was any flaws that were patched. If they were major flaws that we could look at and see if we could get into the web server itself to gain access to the underlying host. It also, you can see it gives several of the headers, XSS protection, X-frame options, X-content type options, some kind of housekeeping issues there. It's saying that those aren't there. That'll give you something to look at when you're looking through the rest of the application as well. That's not something that you're necessarily going to be able to exploit in the strictest definition of a penetration test, but it is something that a client's going to want to know because it is something that they need to put into their application to try to better protect it. And that's one of the reasons I call those housekeeping findings, is because they're really that. It's just kind of, let's put another deadbolt on the door, let's throw a camera up here, let's make sure that we've kind of patched up all the cracks in there. As you kind of scroll down a little bit further, you're looking at mod SSL, mod Perl, mod proxy, Python, PHP, OpenSSL version. In these cases, you might be able to find some flaws in those as well that have been patched since then. Specifically, OpenSSL. If you remember, a couple of years ago, you had a couple of flaws in OpenSSL itself that were exploitable. Heartbleed was one specifically where you could dump memory locations, which could potentially give you passwords. So think about that. You can also see that some of the cookies were set without flags, specific flags that are recommended. Again, more housekeeping kind of things. And then it starts to go and look at directories that it found. So it's going to go pull kind of some common directory names there and report back to you on that. Things you probably want to look at later. There might not be anything in there, but it gives you some reconnaissance to go target later when you're looking at the application itself in the browser. You can go look at the /test folder. Maybe that is where they do unit acceptance testing or QA testing or something, and that application may not be as strongly protected as the production level application. So that might give you some more information that needs to be reported. So just think about it. What's out there that an attacker would want? And that's what you need to go after. So that attacker is going to be looking for any weak spot whatsoever. And so that's really what you need to be looking for. It also shows you that there's a WordPress instance. There's a phpMyAdmin instance. For the longest time, phpMyAdmin was pretty much considered an easy backdoor into any system. There were so many flaws in it. It's gotten a little better, but there's still opportunities for flaws in there to manage the underlying system. WordPress is a common framework that's attacked fairly regularly. People find flaws in that on a regular basis. And we'll go into that a little bit more here in a minute. But another tool you can use is SSL scan. And that will give you, here we're looking at the web server itself, trying to find things from directories and flaws within methods and other things like that. Let's look at the SSL TLS implementation on here. As I mentioned, there was a Heartblade vulnerability. This is checking to see if it's vulnerable to that. There are some vulnerabilities that are specific to the compression algorithms that are used to try to save some bandwidth or make things transfer faster, like the crime exploit. There's other ones that are related to the different algorithms or ciphers that are used. You can kind of pull these together, and most of this you're going to see are going to be things that you want to report back and say, you need to clean this up, you need stronger encryption, but you might still be able to find some flaws that you can exploit here. But a lot of this, things like RC4, MD5, cipher block chaining, CBC, those are all pieces of encryption algorithms that probably should not be used in this case anymore. There's a lot stronger ones out there. These are all considered to be weak, and so you want to report that back to whoever you're testing for so they can make the changes and update this to stronger configurations. Another thing over, you can see that these are still running SSL version 3, which is long now, several years out of favor. And if you are running some, or if you do have a compliance requirement from PCI, like PCI DSS, and the newer versions of that, I think 3.2, which is in effect now, you have to be running TLS v1.2. You can't run SSL v3 at all, and you can't run earlier versions of TLS and be considered in compliance. And so just looking through that will give you a lot of things to call out, more of housekeeping type findings, but still stuff that you want to report back to be a thorough web application tester. It's not fun, but it is part of the job. So from the server side of this, we can start looking into frameworks. And as I mentioned, most web applications are free-form. They're written however the developer wants to write them. So there's not any structure there at all. However that developer writes it to meet the need of the business or the organization is however the structure is. And that's probably going to be different application to application to application. However, we do have some components out there that can be used in these web applications that do have common structure to them. Things like WordPress, Joomla, Drupal, PHPBB, vBulletin, Wikimedia, any of these other sort of base frameworks that stuff is built upon give you kind of a foothold to grab onto when you're doing this testing. And there's tools out there specifically to test these. One of the better known ones is WP-Scan for WordPress. And let's see if I can remember the syntax for this. But if you remember when we did Nikto, we saw this WordPress instance installed at root/WordPress. And yeah, so with some of these tools, they are strict when it comes to the SSL TLS certificates. So you do, in this case, it's not going to be accurate, so we want to disable it. I think curl's the same way. You really have to tell it, I don't care. But this comes up and starts looking very much like what Nikto did, and it gives you a check of what that WordPress instance looks like. As you can see here, it's running, severely outdated. Let's see. WordPress version 2.0, released on the day after Christmas 2005. So extremely old version of WordPress. So it's going to go through and reference some vulnerabilities there, things for you to check. So there's a cross-site scripting, there's some security bypass stuff. These are probably things, if you found this in a WordPress component of an application that you're testing, that you would want to go and look at in that testing apparatus. If you at this point it might not be that big a deal, and you just want to say, hey, your WordPress is out of date, go update your WordPress. There's some more information about themes and plugins it'll give you as well. So it just kind of depends on how you're testing and what the purpose of your test is, as to how you report back on this or use it to further your testing. So now, after going through that, we're now at the browser and proxy level. What a lot of people look at is this is the quintessential web application process, but we've only gotten to that after we stepped up from the network level through the service, through framework, and now we're going to look at it through a browser and a proxy. And so I've been using this Kali VM here, which comes with Firefox. It comes with Burp Suite Community Edition. Burp Suite is probably the most polished proxy software out there. Community Edition is the free edition. It does not have a couple of features that you would want if you're testing this in a real world scenario. If you're out testing for a job or testing for a client, then you want the professional version. What the Community Edition doesn't give you is the ability to save, and it also does not have the active scanner functionality in there. But if you're learning, neither of those really matter, because you don't really need to save when you're learning, and you probably shouldn't be using the active scanner functionality to actually learn how to web app pen test. You need to learn as much manually as possible. When you are using that proxy inserts itself between your browser and the web application. So you want to configure your browser so that you are pointing to the proxy and not directly to the network or the internet. So in this case, most proxies listen on localhost port 8080, and in this case I had it configured from before. So we'll do that. Let's go point at that web application that I was looking at a minute ago. It's running on another VM on my system here. Lovely. Oh, sorry, one thing I forgot to do. Burp, when you start Burp, it comes with intercept on, which is gonna try to stop all of the traffic as you push it through. That's with a proxy. That's kind of the two pieces of functionality are being able to look at what's there, to look at what the traffic has gone through and see all the underlying headers and variables and parameters and everything that's behind there. And then to be able to intercept that so you can make changes. That's why you insert the proxy between the browser and the application, so that when you submit something in a browser, you can come look at it in the proxy, you can alter it if necessary, and then pass that on to the application and see what happens when that comes back. In this case, I had a timeout since that intercept was still on. So now we can see, looking at the same application I was looking at before, there's the WordPress instance that we found. I don't guess they, yeah, doesn't look like they present the PHP my admin on here, but it was there. We found it. So this is a great tool from OWASP as well. Like I mentioned, it's called Broken Web Applications. There's a lot of things. It's got an older version of WebGoat on it. We won't use that older version of WebGoat, but it's there. You've got some older versions, vulnerable versions of software like WordPress, a wiki, Joomla, looks like a picture gallery there too, photo gallery. But you can come in and test those and attack those. But as you can see back here, now when we refreshed, we get a get command pulling the root, and then that's going to ask for these two JavaScript files that go with it. So we can come through and look at these. We can see the parameters. We can look at what is requested. We can look at the response. So you can see all of the HTML and code that comes back. You can try to render it. It's probably, actually in this case, it's fairly simple, so it doesn't look too bad. The rendering doesn't always work that well, just because this is like a JavaScript browser. But you can look at the headers that are returned, the headers that are sent, and these are the things that you want to manipulate through your testing. There is another proxy software out there called Z-Attack Proxy, written by OWASP itself. It is not nearly as polished as Burp, but it is free. You can save files, and it does have scanning ability, but it's not as easy to use. It's not as polished. The scanning functionality doesn't have as much it does not have as much signatures, as much attacks as Burp does. So I just want to introduce you to that. I don't really use Zed or Zap much, other than to play with it a little bit. Whenever I test, I usually use Burp. But Burp's got a lot of functionality. We talked about the proxy quite a bit. When you do tests like something like this, you probably want to come in and you want to add a scope. As you saw so briefly there's a lot of URLs back in the sitemap, a lot of things that are not related to my application at 192.168.114.136. So I can come tailor that scope down to just that, so that when I am sending commands, or doing gets and posts, that I don't see all the other garbage that comes back out. Spider will spider. It kind of walks through the web application to find all the different pieces of functionality, URLs that are in there. Gives you a scope of what you need to test. Scanners, the piece of functionality that doesn't come in the Community Edition, but it's a really great addition to the Pro part, the Pro Edition. You can see it'll come through and attempt command injections, all sorts of different flaws, I mean, for Perl, Ruby, Python, LDAP, XPath, XML, all sorts of wonderful injections. It looks at methods like put, hopefully there's a delete in there somewhere, cross-site scripting, different kinds of cross-site scripting. And so you can see quite a few of those in here. And if you run the scanner, it will take the spider information, or it will spider itself if you haven't spidered, and it will run all of these flaws where they're appropriate in there. If you're running against a decent size application, this can take many hours. The last time I did this, I was running through these on one user interface to an application. I want to say it ran 6 to 8 hours before it was complete. Intruder is a fuzzer. If you want to go through and fuzz inputs, fuzzing is where you kind of brute force. Think of it as if you're doing a password cracking attempt and you're just throwing A, B, C, A, B, A, C. That's what fuzzing is. It does that for the inputs. It's just a little bit more involved. Repeater allows you to go through and take a request to make changes manually and just continually send it to a web server. Sequencer is going to attempt to somewhat a fuzzer with things like session tokens. So if you want to validate the randomness of session tokens, you would use sequencer, and that's important in trying to prevent an attacker from being able to guess an active session token and take over someone's legitimate session. Decoder, anytime you're dealing with web app testing, you're going to decode and encode things a lot. Decode base64 HTML. It's one of the tactics that some developers will use to prevent things like cross-site scripting from being able to be executed. Comparer is just diff for web applications. Diff that's built into Burp Suite. It allows you to look at output from, or really anything, because you're loading it in there, but it tells you where the differences are. So if you're looking at changes in response from one browser agent tag to another, you can drop those both in there and see where the differences are. Extender is something I haven't used, but it's extremely liked by a lot of other people. It allows you to extend the functionality with plugins for Burp Suite. So there are a lot of them in here, but notice that quite a few of those actually require Burp Suite Pro to be able to run those. And then you've got some other options in the other tabs here. But in general, that is Burp Suite. I'm going to leave that running for now because we'll come back and talk about that a little bit more later. And then there's specialty tools, and one specialty tool that I do want to bring up is SQL Map. And I've got a couple of things that I've already run through that I just wanted to demonstrate here. What SQL Map does is it takes a URL and attempts to determine if that parameter is injectable, either in the URL or parameters that you send it separately. And it will try to work through all of the different injection flaws it knows and determine if that parameter is injectable. And so this parameter, I've run it before. I know it's injectable, and we've done most of the work here. This takes time. It goes through a lot, but we've run it. I don't want to spend a whole lot of time running through this here, but what this does is it has tested this one parameter, ID, and determined that it is injectable. It's found out what the fingerprint of the database is MySQL. And so we can take that and we can say, okay, now that you've found that that's injectable, tell me what databases are behind that. And so again, I've already run this through once, but it comes back and says, oh, here's all these databases that are in that DBMS. And so as you can see, it's most of the ones that have to deal with the applications that were on the front page of the web server I showed you. And so once you do that, you can say, okay, let's take that WordPress database and show me what tables are in there. And I haven't run this. I want you to see what this looks like when we're doing this. But what this is going to do is step through like blind injection and try to enumerate the tables that are in that database. And you can see it's talking about time delays and time-based comparisons. You can watch this as it steps through enumerating these tables. And it looks like we're running on a really, really old modem here, because it's having to step through kind of all the options and look for which letter took a different amount of time to return. And so this is really kind of the speed that this happens. Now imagine trying to do this manually. You would never get this done. In the past, people would write specialty tools for the individual instance that they were testing to be able to do this. But in more recent, we've gotten tools like SQL Map to be able to do this for us in a more automated fashion. And there is an extension in Burp Suite that will allow you to run SQL Map within Burp Suite and see all this. So I'm not going to let this run anymore. This is going to go through and just enumerate all the tables, and it's going to run about that fast through the remaining time it does this. But you get an idea there. So once you find those injectable areas, then you step through this in succession, and you'll get more and more to work off of. And you can use that as you step through to actually dump the contents of those tables and give you the full information out of each of those tables in the database. So that's all of the tools. Now let's step into the learning portion of this. What can you pick up, take away from this that you can use to help better understand how to do web application testing, or learn on your own to become a web application pen tester at some point? And the first thing I recommend is this book, the Web Application Hacker's Handbook. It's basically the Bible for learning how to test web applications. It's fairly lengthy. It's 800 plus pages, but it steps through all sorts of scenarios. It talks about all the different areas. It's very well organized. It's a fairly good read, fairly lengthy. I'm not a big reader myself, but I've read both the first edition and the second edition. When I started, the first edition was still fairly new. The second edition is a bit old, but it's still good information. A lot of the core of what web application testing has not really changed since it was published. The writers here are actually the Burp Suite guys. So you know there's some good pedigree there when it comes to this. Next thing, and what most of you came here to talk about, or what most of you came here to learn, is WebGoat. And we'll step through that a little bit. So let's actually walk back over here. WebGoat is an OWASP tool. As I said earlier, you'll hear OWASP, OWASP, OWASP. There's just a lot of stuff there. So just search OWASP WebGoat in Google, or you can go to owasp.org and navigate through to WebGoat. But then you can install it a couple of ways. You can install it in Docker, or you can just take it and run it as a Java file. And I recommend running it just as a regular Java file. It's just a jar file that you can run whenever you want to use it, and don't leave it up and running because it is fairly vulnerable. But once you download that jar, which I've done over here, you can just start it up. And it's very simple: Java-tech jar, WebGoat, blah, 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 version number. I add the server.port 8008 tag on there as well, because it's normally going to run on 8080, which is the same port that your proxy listens on. So to keep them from clashing, I tell WebGoat to listen on a different port. So you'll see it'll take some time to start up. It's actually loading all the lessons, all the modular lessons in there. You'll see them, yeah. So you see lesson loaded. And so in this case, in burp, I'm going to go back to target, and I want to remove that target, or it's not going to work anymore, or I'm not going to be able to see what I'm doing in WebGoat in Burp Suite, because I had it narrowed down to the other VM, and I'm going to run this one localhost. Actually, I'm going to go close Zap as well. So when you first connect, I think I've erred here too. I always forget this. I just told you that I loaded it on port 8008, yet I skipped right over that. Oh, yeah. And it's not encrypted. So there we go. Sorry about that delay. So in this case, you'd want to come in and register as a new user. I think I have a user account already. And from there, it walks you through everything. So even the introduction here, you can learn about WebGoat. WebWolf is another part of it where you can look at the interaction between the server and the client. I believe it's something that's it's a little bit newer, so I don't have experience with that. But as you step through this, you just walk through the lessons. And so here, something as simple as what's your name, and you can come back and look at how that looks in the proxy. I think it's because well, no. So we got that, and let's post and 12, just for grins. So let's come back and see. Yeah, so there we can see that. So in that case, whoops, we can look at what happened in there. And so it's going to ask you these things when you went and you did the entry and submission in the previous one. Was it a post or a get? In this case, it was a post. I looked at it before. I know what it is. It's a post. The magic number is random each time, so you can just throw that in there and hit submit. It'll tell you it's wrong, but then you can use the proxy to come back and say, oh, look, this hidden parameter back there says magic num equals 20. So I'm going to assume that's what it was talking about here. Yay, it was what it was talking about. So those little things and getting you accustomed to using a proxy, a web proxy tool, understanding the components of a web request and response and things like that. That's what WebGoat's all about. You can go down and look at things like SQL injection. Let's walk through that one real quick. And it steps you through gradually to help you understand what what SQL is, what's a SQL injection, what can happen, what's the risk in it. And then it gives you some very basic examples of how you would do that. And then it comes in and says, okay, now do it. And so you can read how and why this works in Web Application Hacker's Handbook. It walks you through in detail to understand what's going on here. But in short, what you're doing is you've found a dynamically executed SQL statement in the application, and you're exploiting that by closing out the existing SQL statement and giving it, in this case, a SQL, a OR statement that is always going to evaluate to true. So you're saying whatever I put in the other one, or true, so that it's everything in there is going to come back and say, okay, everything is true because of that OR statement there. It's always going to evaluate to true, so it's just going to dump everything out. And in this case, you can see that's what it did there. This is extremely basic, and I doubt you will ever find something like this in the real world, but it gives you an idea of what a SQL injection is at the very foundational level. And so that's all WebGoat is to the rest of this. It steps you through other things, cross-site scripting, authentication, access control, other things in there. So you look at the technical side of web application testing here. There's also business logic when you're testing out the applications. That's a big part of that, but we won't really get into that here because that's going to be very specific to the application. You have to understand the division of the roles and what the real world implications of those roles are. So we're just looking at the technical side of things here. And then finally, VulnHub, which is where I found the OWASP Broken Web Applications VM, but you can also get that off of OWASP. You can come here and you can pull any kind of vulnerable VMs here, not just web application practice machines. You can search for different kinds of things. You can just browse. But this has been around for a few years, and it's just very full of this user-created content for testing, practicing, learning, whatever you want there. Okay, so we talked about the controls, what we're testing to, the flaws that we're looking for. We looked at tools that we use through testing, from very basic network level stuff all the way up to the highest level application testing. And then we looked at the avenues for learning and the resources for learning this on your own and what they are out there. So I really hope you guys got something out of this. You can take this and you can start building yourself into a web application tester. So thank you.